Welcome to the deep dive. Today, we're really digging into something fundamental for cloud work, AWS encryption.
Yeah, it's pretty crucial stuff.
Absolutely. We'll be focusing specifically on Amazon S3, EBS, RDS, and the big one, AWS Key Management Service, or KMS.
Hmm.
We've sifted through a whole stack of material on how encryption works across these services, and our mission today, basically, cut through the noise, pull out the really important bits,
Right.
and hopefully give you those aha moments so you can really get your head around protecting data in AWS. Make it simpler.
Sounds good. Let's do it.
Okay, so let's set the scene a bit. Why encryption? I mean, it sounds obvious, but why is it absolutely essential, not just a nice to have, especially in AWS? What problems does it actually solve for you?
Well, the core problem it solves is pretty fundamental.
Mm-hmm.
It's data security risk, plain and simple.
Right.
If data isn't encrypted, it's just vulnerable to breaches, to interception, someone getting unauthorized access. Doesn't matter if it's sitting still or moving around.
Yeah, makes sense.
So these services, they're really designed to protect that sensitive stuff. You know, customer details, financial info, media files, whatever it is. It's about keeping it confidential, but also making sure it hasn't been messed with. Integrity.
Keeping secrets secret and making sure they stay that way. Got it. But beyond just keeping data private and untampered, what else? Is there like a regulatory angle pushing this too?
Oh, absolutely. That's the huge driver, maybe even bigger these days. Compliance.
Ah, compliance, right.
Yeah, regulations like GDPR, HIPAA, PCI DSS.
Yeah.
They don't just suggest encryption, they mandate it for sensitive data, both when it's stored data at rest and when it's moving in transit.
So it's not optional if you fall under those rules.
Pretty much non-negotiable. And the real aha here, I think, is how AWS has kind of democratized this level of encryption. What used to need, crypto experts and expensive hardware, you can often just enable with a few clicks now. It changes the game from how do I even do encryption to, okay, what data really needs encrypting for my business?
That's a great point. So security risk and compliance needs. In your experience talking to companies, which one usually lights the fire first? Is it the fear of getting hacked or the auditor knocking on the door?
Yeah, it's often a mix, but that auditor demand, especially when there are big fines attached, that tends to be the immediate push.
Right.
Fear of a breach might start the conversation, maybe gets the budget allocated, but the compliance deadline, that often sets the actual timeline. It's concrete.
Understood. Okay, let's introduce the main players we're focusing on today. 4 key services. We know the basics, but how do they fit into this whole encryption picture?
Right, so think of it like this. First, you've got Amazon S3. That's the massive object storage, great for backups, archives, website assets, you name it.
Okay.
Then there's Amazon EBS, Elastic Block Store. That's basically the hard drives for your EC2 instances, your virtual servers. Persistent block stores.
Got it, the virtual disks.
Exactly. Third is Amazon RDS, the relational database service. So managed databases like MySQL, Postgres, SQL Server.
The brains for many applications.
Definitely. And finally, kind of tying it all together, is AWS KMS, Key Management Service. That's the central hub for managing all the encryption keys.
Okay, so different kinds of storage objects, blocks, databases, and then this central service, KMS, managing the keys for them. How does AWS handle encrypting data across these? Like when it's just sitting there versus when it's moving?
Yeah, so AWS covers both scenarios, data at rest when it's stored on disk in S3, EBS, or RDS, and data in transit when it's moving, say, between your app and the database or you uploading to S3.
Okay.
But the real clever part, the secret sauce maybe, is how KMS integrates. It's the brain, like you said. It makes managing the actual cryptographic keys, which used to be a massive headache, much, much simpler.
How so? What was the headache before?
Oh, it was complex, error-prone. You might have keys scattered everywhere, maybe insecurely stored, hard to rotate, hard to track who used them. KMS centralizes all that across S3, EBS, RDS, and loads of other services. It takes away a lot of that operational pain.
Right, simplifies a complex problem. Okay, let's dive into each one then. First up, S3, object storage. What exactly are we encrypting here, and why is it so critical for stuff like customer data or backups?
So with S3, you're encrypting the individual objects themselves, the files, the data blobs, living inside your S3 buckets.
Okay, the files themselves.
Exactly. And because S3 is often where people put really sensitive stuff, backups, customer records, financial reports, media files, encrypting it is vital. It protects that data if someone somehow gets access to the storage itself, keeps it confidential. You definitely don't want your customer database just sitting there unencrypted in a bucket. right?
Absolutely not. So how does S3 actually do the encryption when the data is at rest? What are my choices?
Okay, for data at rest, S3 mainly uses what's called server-side encryption, or SSE. Basically, AWS handles the encryption for you as the object is written.
Server side. Got it.
And you've got a few main flavors. First, SSE S3. This is the easiest.
Yeah.
AWS manages everything, the keys, the encryption. Using AES 256, you just tick a box, pretty much.
Simple.
Yep. Then there's SSE PMS. This uses keys that are managed by AWS KMS. Gives you more control.
Ah, KMS integration.
Exactly. The big win here is you get audit trails from KMS who use the key, went into BAM, and you can manage key revocation policies centrally in KMS. More visibility, more control.
Okay, that sounds powerful.
Then there's SSEC. That stands for Customer-Provided Keys. This one's different. You create and manage the encryption key yourself.
Oh, okay.
And you have to send that key along with every single request to upload or download the object. S3 uses it, encrypts, decrypts, and then immediately forgets the key.
Wow, okay. Why would someone choose that? Seems like more work.
It is more work, but some organizations have really strict rules, maybe regulatory, saying only they can handle the master key. So it gives them that control, even though it adds operational overhead.
Makes sense. Any other options?
Well, there's also client-side encryption. That's where you encrypt the data before it even leaves your environment and goes to S3. You manage the keys, maybe using the KMS SDK or your own tools.
Right, encrypt before uploading. Got it. What about data in transit for S3? Do I need to set that up too?
Nope, that's generally handled for you. When you upload or download via the S3 endpoints, it uses HTTPS, which uses TLS encryption. So the transfer itself is secured by default.
Okay, good. That SSE stuff sounds powerful, especially SSE S3 and SSE KMS. How easy is it to actually turn this on? And thinking back, before AWS made this easy, what was the alternative? What pain does this solve?
It's incredibly easy now. Often, it's literally setting a default encryption policy on your S3 bucket in the console. One click, and all new objects get encrypted automatically. Or you choose when uploading.
Wow.
The pain it solves.
Yeah.
Huge. Think about old school file servers. Data was often just there, unencrypted. Maybe the network perimeter was secure, but if someone got inside or got hold of a backup tape, game over.
Yeah, I remember those days.
S3 encryption protects the data at the object level. Even if someone bypasses other controls and accesses the raw storage, the data itself is scrambled gibberish without the key. It's a massive step up, and it's now super accessible.
Okay, moving on from objects in S3, let's talk EBS, the block storage for EC2 instances. What's the deal here? Why encrypt these virtual hard drives, especially for things like, say, financial apps?
Right, so EBS volumes are the persistent storage for your EC2 instances. Think of them as the C drive or D drive. Encrypting them is crucial because they often hold operating systems, application code, databases, temporary files, lots of potentially sensitive stuff.
So the actual running data of the server.
Exactly. For data at rest, EBS encryption scrambles the data on the volume itself and also any snapshots created from that volume. Uses AES 256, and again, you can use keys managed by AWS automatically or keys you manage in KMS.
KMS again.
KMS again, central. And importantly, the data moving between the EC2 instance and the encrypted EBS volume is also encrypted. That's handled in transit within the AWS infrastructure.
Does encrypting the EBS volume slow things down, like impact performance? And what exactly gets encrypted? Just the data files.
Good questions. AWS says there's minimal performance impact. They've built it into the hardware virtualization layer. So generally, no, you shouldn't see a slowdown.
Okay.
And its scope is comprehensive. It encrypts the volume data itself, any snapshots you take of the volume for backups, and crucially, the data moving between the instance and the volume, the disk I/O. All encrypted.
That's pretty thorough.
It is. It protects the data even if someone can somehow physically access the underlying storage hardware or if the snapshot was improperly shared.
Right.
Compared to unencrypted disks on-prem, it's a huge security improvement, easy to enable when you create the volume.
Okay, so we've covered encrypting objects with S3 and the virtual disks with EBS, but what about the heart of many applications, the database itself? Especially with sensitive stuff like patient records or e-commerce orders. How does Amazon RDS handle encryption?
Right. RDS manages relational databases for you, and yeah, they often hold the crown jewels data-wise. So encryption is critical. For data at rest, RDS encryption covers the whole database environment. It encrypts the underlying storage for the database instance, all that automated backups, any read replicas you create, and manual snapshots.
The whole shebang.
Pretty much everything. It uses AES 256, and crucially, it always uses keys managed by AWS KMS. There's no option like SSES3 here. It's always KMS backed for RDS encryption.
Always KMS for RDS. Okay. And in transit.
For data in transit, RDS uses standard SSL-TLS to encrypt the connection between your application client and the database endpoint. You just need to configure your app to connect using SSL.
Makes sense. Now, when can you turn on RDS encryption? Is it flexible like S3 or are there rules?
This is a really important point for RDS. You must enable encryption when you create the RDS instance.
Oh, only at creation.
Only at creation.
Yeah.
You cannot encrypt an existing RDS instance that was created without encryption. You'd have to create a new encrypted instance and migrate the data.
Wow. Okay. That's a big gotcha to remember.
Definitely. Plan ahead. But the good news is, if your main instance is encrypted, any backups, snapshots, and read replicas created from it are automatically encrypted too. It maintains that protection. And it works across most of the popular engines: MySQL, Postgres, Oracle SQL Server, MariaDB.
So a huge step up from potentially leaky legacy databases, but you got to enable it from the get-go.
Exactly. It secures that sensitive data right in the database core, which was often a major vulnerability in older setups.
Okay, we keep coming back to KMS. You've called it the central brain, the secret sauce. Let's unpack that. What exactly is AWS KMS, and why is it so fundamental to S3, EBS, and RDS encryption?
Right. AWS KMS Key Management Service is fundamentally a managed service designed purely for creating and managing cryptographic keys. That's its job.
Just keys.
Just keys, but it's huge. It handles both symmetric keys, the kind typically used for encrypting bulk data like an S3, EBS, RDS, and asymmetric keys, which are public-private key pairs, used more for things like digital signatures or specific encryption schemes. Its real power, though, comes from its integration. It's built to work seamlessly, natively, with almost every other AWS service that needs to encrypt something. S3, EBS, RDS are prime examples, but there are dozens more. It provides that central, secure place to manage the keys that lock and unlock your data across the platform.
So it's the integration and centralization that make it powerful. What are some key features that really stand out, things that make life easier or more secure?
Yeah, there are several big ones. First, key rotation. For the keys that KMS manages for you, like the default keys for EBS or S3 when you choose SSE KMS, it can automatically rotate them every year. New key material, old key still works for decryption. Enhances security, zero effort for you.
Automatic rotation, nice. What else?
Access control. This is critical. You use standard AWS IAM identity and access management policies to control exactly who or what, like an EC2 instance role, can use a key or manage key. These privileges built in.
Fine-grained permissions, good.
Very good.
Yeah.
And maybe the most important for many folks, especially compliance, auditability.
Ah, the logs.
Exactly. Every single time a KMS key is used, created, disabled, deleted, and crucially, used for encryption or decryption by S3, EBS, RDS, whatever, it gets logged in AWS CloudTrail.
Every single use.
Every use. You get this immutable audit trail showing who used what key, on what resource, when. For proving compliance or investigating potential issues, that's absolute gold. Verifiable proof.
That sounds incredibly valuable. You mentioned before that managing keys used to be a nightmare. Can you paint a picture? Before KMS existed, say, pre-2014, how did people do this? What were the challenges?
Oh, man. It was tough. Really tough and error-prone. Organizations might have relied on just manual processes using tools like OpenSSL for encrypting files, which is tedious and easy to mess up. Keys might get stored insecurely, maybe hard-coded somewhere.
Yikes.
Or for more security, they might invest in really expensive on-premises hardware security modules, HSMs. These are secure, but they're costly, need specialized skills to manage, don't scale easily, and become single points of failure.
Right, big physical boxes.
Yeah. And honestly, a lot of organizations just didn't encrypt everything because the operational burden of managing keys properly was just too high. The risk was accepted because the alternative was too complex or expensive.
So KMS basically democratized secure key management.
Absolutely. It took away the need for that huge capital expense on HSMs, simplified the operations massively, and provided this centralized, audited, highly available platform for keys integrated right into the services people were already using. I remember teams spending ages just managing SSL certs, let alone application keys. KMS just eliminates so much of that pain.
Okay, so we've gone through S3, EBS, RDS, and KMS. We see how they encrypt things. Let's tie it all together. What does this whole setup mean for someone just trying to secure their data day-to-day? How does it connect?
Well, connecting the dots, these services directly tackle those core problems we started with, right? You get genuinely enhanced data security because encryption is robust and often automatic. You get simplified compliance because meeting those regulatory checkboxes is way easier, often built in. And you get that centralized key management via KMS, which solves the massive historical problem of keys being scattered everywhere and poorly managed. And maybe the biggest thing is the ease of use.
The checkbox simplicity.
Yeah, enabling encryption is often just a configuration setting, maybe a policy.
Mhm.
It's worlds away from the manual, complex methods of the past.
Mhm.
It makes really strong security achievable for almost anyone on AWS.
Can you give us a concrete example, like a real-world scenario showing the before and after transformation?
Sure, let's use that healthcare company example. Dealing with super sensitive patient data, right?
Yeah, IPA territory.
Exactly. So before AWS, they might have had databases running on servers in their own data center, maybe unencrypted, because setting up database encryption was complex and potentially impacted performance with their older gear. Key management, probably ad hoc, maybe keys stored in config files, difficult to rotate, hard to audit, constantly worried about HIPAA compliance, potential breaches, just a stressful situation.
Sounds familiar for many older setups.
Right. Now with AWS, the mixture is totally different. They migrate their database to Amazon RDS. They enable encryption at creation using KMS. Instantly, the database instance, backups, replicas, all encrypted at rest. Secure. Audited.
Okay.
Their patient portal application runs on EC2 instances. The underlying EBS volumes are created with encryption enabled, again using KMS keys, so the OS, the app data, the disk I/O, all protected. And for long-term archiving, maybe medical images or old records, they use Amazon S3. They set a bucket policy for default encryption using SSE KMS. Every file uploaded is automatically encrypted, keys managed and audited by KMS.
Really integrated.
Exactly.
Mhm.
Security and compliance become much less of a constant battle. It's built-in,
Yeah.
manageable, auditable. That's the power of these services working together. It solves real, tangible problems.
That paints a really clear picture. So we've really dug into AWS encryption today, S3, EBS, RDS, and the linchpin, KMS. Hopefully we've demystified some of it, turned the jargon into something more concrete about keeping your cloud data safe.
Yeah, and I think just understanding these building blocks, how they work, why they exist, really empowers you. It lets you build much more secure, much more compliant applications and systems in the cloud. Gives you confidence,
Definitely. Knowing your data is protected at rest, in transit, with keys managed securely, that's huge.
Absolutely.
So maybe a final thought to leave our listeners with. We've talked about how easy AWS makes powerful encryption now. It's so much more accessible than it used to be. Does this shift in accessibility change things for us? Does it change our responsibility personally or as organizations for being proactive about security? And maybe what new possibilities does this unlock for truly safeguarding information in this hyper-connected world we live in? Something to think about.